Hello, my name is Henry Zhang. I'm Application Engineer Manager for Power Product at Linear Technology. Today, I want to show a performance difference between voltage mode and current mode control in a polyphase power converter. Let me start my discussion with the basic concept of voltage mode and current mode controls. And here's a simplified circuit diagram of voltage mode control buck converter. The feedback loop sends the output voltage and compares it with the internal resonant voltage. The difference, which we call error signal, goes through the compensation network. And the output of the error amplifier compared with the slope compensation signal and generate duty cycle. That's how the buck converter works, and it's very simple and straightforward. The current mode control is a little bit more complicated, but with more reliability than voltage mode control. It is implemented by adding an internal current sensing feedback loop. This current sensing feedback loop is faster than the external voltage feedback loop. By doing this, the loop here forces the inductor current to follow the error amplifier output voltage. Here's how the current mode control buck converter works. At every time the internal clock turns on the top side MOSFET here, that's the start of the duty cycle. Then the inductor current goes up until the inductor current reaches the error amplifier output voltage. At this moment here, the top MOSFET is turned off and bottom MOSFET is turned on. That's the end of the duty cycle. By doing this, the current loop forces the inductor current to follow the error amplifier output in the cycle-by-cycle way. This makes current mode control very reliable. In high current application, while many channels need in parallel, it is important to have good current sharing among channels to balance thermal stress and avoid inductor saturation. Unfortunately, with the voltage mode control, as you can see, voltage mode control requires a fairly complicated current sensing network and current sharing network. Besides, the external current sharing network has to be slower than internal voltage feedback network, otherwise the loop will become unstable. Current mode control makes current sharing very simple and straightforward. As you can recall, in the current mode control, the inductor current will have to follow the error amplifier output voltage. In this case, we just use a single error amplifier and share the error amplifier output voltage among channels. By doing this, naturally, you have a good current sharing among channels. And this is an inherent current sharing, which is also a fast cycle-by-cycle current sharing. Regardless of voltage mode or current mode control, if you open a vendor datasheet, you usually see very good current sharing curves or waveforms that shows the perfect matching between channels. However, what I want to remind you today is this nice current sharing curve or waveforms are only for condition which we call DC current sharing or steady state current sharing. What the vendor don't show you is the dynamic current sharing for the condition on the transient, such as power up, power down, low step, or short circuit conditions. The current sharing under those conditions are important, and that's something I want to show you today. Here are the typical waveform of a voltage mode control converter with slow current sharing loop. It's taken with a three-phase buck converter. The waveform here is output voltage, and the waveform here in three different colors, yellow, purple, and green, are the inductor current waveform. As you can see, although the inductor current have perfect current sharing in the DC condition here, however, at a low step transient, you see a clear mismatch between the inductor current waveform. This mismatch means one channel will handle too much current, which will end up inductor saturation or potentially damage the MOSFET. Besides, if this low step happens at a high speed and high frequency, this mismatch could cause a thermal problem as well. Here are the typical waveform of a current mode control converter at a low step. This is taken from the LTC 3731 three-phase single output buck converter with peak current mode control. The waveform here are the three-channel inductor current waveform. Remember, with the current mode control, you have fast cycle-by-cycle current sharing. Therefore, you have almost identical waveform between these three channels. You have a good current sharing in both DC, low step up transient, and low step down transient. In summary, current mode control offers you fast and simple current sharing. Thank you for your time. For more information, please visit the Linear Technology website.